Yeah, so the title is Fitch's Paradox of Knowability and Empirical Negation. And if you didn't see the abstract, here's the plan. So I'll propose what I think is a simple and natural intuitionistic solution to Fitch's paradox that doesn't rely on restricting the verificationist principle, which is not a strategy that I prefer. The principle that all truths are knowable. So the proposal turns on an understanding of negation that's applicable to empirical discourse, which is essential to making sense of verificationism in the first place, since we're talking about the knowability of a proposition, or whether a proposition is known, and so on. And those are empirical propositions. So according to a popular brand of anti-realism, every truth is in principle knowable. So we have this anti-realist, I'll call it AR, principle that for all propositions P, if P is true, then it's possible to know that P. So even if one thinks that, say, this principle is false, it seems, at least on the face of it, that it's not, paradoxical or inconsistent. It looks like a defensible position. Now, it's a principle that many people, especially Dummett, who I'll talk about, defends, or something like this, as we'll see, and many others would subscribe to some principle along those lines. It's a formalization of what's sometimes called this intuitive principle that truth is epistemically constrained. However, if we grant that there are unknown truths, at least one unknown truth, here's an example, for instance, concerning the number of books on my shelves, which nobody has bothered to count. Maybe there's 50 of them. Then it would be true that there's 50 books on my shelf, but nobody knows it. So as long as we grant that there are unknown truths, then AR leads to the conclusion that every truth is in fact known. So we get that formula on the bottom for all P. If P, then P is known. So some people put it, the diamond disappears from AR. Now here's a proof of it, a sort of standard-ish looking one. So you have an assumption 1 that there is a proposition P that's true and not known. And then 2, let's call P an existential witness to 1. So we have P and P isn't known. And from that and the anti-realist principle, we get it's possible to know 2. So we get it's possible to know that P and P isn't known. Now, if we assume the thing without the diamond through without the diamond, then we're led to a contradiction. So we have assumption 4. Suppose that it's known that P and P isn't known. Then K distributes over conjunction. So you get 5. Since knowledge is factive, you get from 5, 6, KP and not KP by applying factivity, the right conjunct of 5, and doing propositional logic. And then that's a contradiction. So by intuitionistic reductio, from 4 and 6, we get 7. So it's not the case that that knowledge claim is true. And then since that's we've proved that, then we can necessitate it. So we get 8, and then we use 1/2 of a duality principle between the box and the diamond, and that gives us 9. And that, of course, contradicts assumption 3. That contradicts assumption 1. So we use reductio, and we get it's not the case that there is a unknown truth, which is line 10, and that's intuitionistically equivalent to 11. That for all P, if P is true, then it's not the case that P is known. And then using double negation elimination, we get 12. So for all p, if p is true, then p is known. Now, if you look at this proof, you can see that most of the principles used don't look implausible. They look quite plausible, except the last step in the proof, of course, is only classically acceptable and not intuitionistically. But everything else looks more or less fine. Distribution of K over conjunction, factivity, and so on. Now, one popular, I guess, or at least well-known response by the intuitionist to this paradox is dumb it, and it's also defended by David Davidi and Graham Solomon in a paper in I think the 90s as well. And this is what dumb it has to say. So reject the last step of the proof and embrace the penultimate line that for all p, if p is true, then it's not the case that it's not the case that p is known. He says the double negation of kp means, quote, there is an obstacle in principle to our being able to deny that p will ever be known. So in other words, the possibility that p will come to be known always remains open. So that's how we should read the double negation of p. So that this holds good for every true proposition p is precisely what the justificationist believes. This is the principle expressed by line 11, the penultimate line. And that line captures the relation which the justificationist believes to obtain between truth and knowledge, namely that if p is true, then the possibility that it come to be known always remains open. So the reason the penultimate line looks implausible, so says Dummett, is or stems from a misunderstanding of constructive negation. So if you actually read it in this really strong way, as saying that there is an obstacle in principle, ... then that penultimate line, which the intuitionist has to accept, isn't that bad. What would be bad, of course, is the final line where you remove those two double negations, but the intuitionist is not committed to that. In the Solomon and Davidi paper that I mentioned, they, of course, make use of Kripke semantics for intuitionistic logic. And there, that double negation acts kind of like a diamond operator. So the double negation says that basically the double negation of a proposition means that it's sort of inevitable for every extension of the current state. There is an extension of that state at which p is true. So it's like a diamond, sort of. And so there you can see how maybe that relates more to the original principle AR. Now, there's a few responses to Dummett, or objections to Dummett, that I want to just quickly discuss, but I don't want to focus on Dummett's or really any of the other solutions, of the many solutions that exist to this paradox. I just want to sort of discuss one that I think is a natural one, but I do want to look at Dummett's because it's a well-known constructivist response. So if p was once true, but all the evidence for p no longer exists, then it seems simply false that the possibility that p will come to be known always remains open. So here p could be an empirical proposition, not a mathematical one, like concerning the number of hairs that was on the head of somebody who's long passed. So Dummett discusses this case, actually, but what I think he does is that he assumes a rather trivial notion of epistemic possibility that couldn't really be the notion that's applicable to what it means when we say it's possible to know that p in the anti-realist principle. So he says, in Kuhn's example, that will never be known whether the number of hairs on his head at a certain time was even or odd, would seem to be the safest of predictions. We can safely assume that that will never be known. And one of those is true. Either he had an even number or an odd number of hairs on his head. But it seems like we could never know it. So if we can say anything about the future with virtual certainty, then surely we can say this. But when the point is pressed as hard as possible, we cannot absolutely rule out that some means of deciding the question, now wildly unexpected, may come to light. Say some physiological condition proves to be correlated with the parity of the number of hairs on his head, and it can be determined whether Professor Kuhne was in that condition at that time. Um, yeah, so that's what he says. It seems to me a pretty far-fetched response to this counterexample is to say that, well, um, it's true. So we have to say that there is some possibility, no matter how far-fetched or whatever, that we come to know it. Maybe we can time travel, go back and check, or maybe there's a physiological condition correlated with the number of hairs on the head, which seems to me obviously wildly implausible. Um, Now, if that's a sense of being possible to know that, then I mean, in some sense, not everything, including falsehoods, negations of logical contradictions, in some sense, seem to be at least we have to leave open the possibility that they come to be known because, well, maybe physics tells us that we have to give up some logical law or whatever, such as the law of distributivity or whatever. But this is a very weak understanding of epistemic possibility. Um, it's a rather trivial notion. Almost anything becomes epistemically possible if we don't know it to be true or false. But I don't think that's really the relevant sense of possibility. But anyway, so that's one objection to Dummett. Another one is that given the intuition and strong reading of negation as sort of this kind of refutability or impossibility, there's simply no way to express that a proposition is unknown rather than unknowable. Yet it's clear that in discussions of Fitch's paradox, the weaker reading of negation is assumed, according to which, when we say that P is true but unknown, so this proposition here, I don't know, can you see my cursor when I move it on my screen?
Yep, you can see that.
Oh, okay. So that's read as P is true but unknown, and not as P is true but unknowable. So all the discussion was about P is true but unknown. That was the first assumption of the proof. Of course, if we read it in this really strong way, as P is true but unknowable, then even line 1 of the proof would be rejected by the anti-realist. So the proof wouldn't even get off the ground on line 1. So then what's the point of discussing the plausibility of line 11 anyway? Because you can reject that there exists a P such that P is true but unknowable. That would be the first line of the proof. So, and a last one is a bit of an ad hominem, but Dummett thinks that applying intuitionist negation to empirical statements is problematic since he thinks it's not clear what the empirical analog of proof should be. So it's not even clear whether the intuitionistic negation of an empirical proposition, such as KP or not KP, to KP, is even meaningful if understanding the negation that way is sort of like this arrow falsum definition where not KP means KP arrow bottom. So if you understand the connectives in terms of the BHK clauses, you would have to have some sort of analog of proof where you'd be able to convert some verification of the antecedent into a verification of a falsum. And it's not clear what that would be. So it's not clear that this response even works if the negation is not really applicable to empirical discourse. So that's sort of the point with these two objections. Now, the proposition that P is known or not is, as I said, an empirical proposition. You can't come to know it, for instance, a priori. Thus, any constructive solution to the paradox must interpret negation as applicable to empirical and not just mathematical propositions. We want to know whether, when we state that P is unknown at present, that's an empirical proposition. Now, intuitionistic negation is too strong, as I mentioned, to express that a proposition is unknown, and can only say that a proposition is unknowable. And I think I already mentioned that, so I'll just skip that little bit there. But so what I'll do later is distinguish two types of negation: a weaker empirical one and a stronger intuitionistic one. So the empirical negation, as I'll write using this squiggly symbol here, P, not P of a proposition P, expresses something like there's a lack of sufficient evidence at present to warrant the assertion of P, or to assert P. Well, whereas the intuitionistic negation over here using the standard symbol, not P, asserts the stronger proposition that there couldn't in principle be sufficient evidence to assert that P. So you can refute P. So it's a much stronger assertion. Now, this notion of empirical versus, say, the arrow falsum sense of, or mathematical negation isn't new. And Heiting in 71 says this about it. He called it factual negation. He says, in mathematical assertions, no ambiguity can arise. Not has always a strict meaning. The proposition P is not true, or the proposition P is false, means if we suppose the truth of P, we're led to a contradiction. But if we say that the number generator Q, which I defined a few moments ago, isn't rational, this is not meant as a mathematical assertion, but as a statement about a matter of fact. I mean by it that yet no proof for the rationality of Q has been given. As it's not always easy to see whether a sentence is meant as a mathematical assertion or as a statement about the present state of our knowledge, it's necessary to be careful about the formulation of such sentences. Where there is some danger of ambiguity, we express the mathematical negation by such expressions as it's impossible that, it's false that, it cannot be, so these kind of modal locutions, etc. While the factual negation is expressed by we have no right to assert that, or nobody knows, etc. And Dummett has something similar to say. He says, a reluctance to say that pi was not transcendental before 1882 is not merely a lingering effect of Platonistic misconceptions. It is rather because to speak in this way would be to admit into mathematical statements a non-intuitionistic form of negation, as will be apparent if one attempts to assign a truth value to the statement, pi is not algebraic, considered as a statement made in 1881. This isn't because not, which occurs in ... is not true or was not true, sentences of that form, is non-constructive. We may reasonably view it as decidable whether or not a given statement has been proved at a given time. But though constructive, this is an empirical type of negation, not the negation that occurs in statements of intuitionistic mathematics. The latter relates to the impossibility of ever carrying out a construction of some fixed type, the former to the outcome at variable times of some observation or inquiry. And of course, this temporal element not being proved at a particular time is an empirical fact. And one last quote from Dummett again is this. So, of course, we know he thinks that applying intuitionistic negation to empirical statements is problematic, but he also thinks it's problematic what the correct negation is for empirical discourse. He says, negation is highly problematic. In mathematics, given the meaning of if-then, it's trivial to explain not A as meaning if A then 0 equals 1. By contrast, a satisfactory explanation of not as applied to empirical statements for which bivalence is not in general taken as holding is very difficult to arrive at, given that the sentential operators cannot be thought of as explained by means of the two-valued truth tables. The possibility that the laws of classical logic will fail is evidently open, but it's far from evident that the correct logical laws will always be the intuitionistic ones. More generally, it's by no means easy to determine what should serve as the analog for empirical statements of the notion of proof as it figures in intuitionist semantics for mathematical statements. So he has some reservations of what the correct negation is for empirical discourse. And he leaves open, of course, it's not going to be intuitionistic or classical. Now, this is these are the BHK clauses, I'm sure, as everybody is familiar with, for the standard intuitionistic connectives in terms of proofs. So a proof of a conjunction consists of a proof of each conjunct, and depending on how you think of proofs, say followed by the statement P and Q, their conjunction. And a proof of a disjunction would be a proof of one of the disjuncts followed by P or Q, and so on. Now, one sort of Demetian version of sort of extending this interpretation of the connectives to empirical discourse is to replace proof everywhere in them with something like a verification. So a verification would be the analog of a proof. So you can, verify empirical propositions in many ways by perception, by doing tests or whatever. And those things would count as analogs for proof. Now, there is a question of whether verification as some notion of evidence or something should be defeasible or not. I think if you read them this way, then no, it shouldn't be. So when I talk about a verification of an empirical proposition, it should be something that's, guarantees sort of the confirms the proposition to a high degree. Like it couldn't be defeated, let's say. Now, on my preferred account of empirical negation, to say that an empirical proposition P is not the case is to assert that there fails to be sufficient evidence now, at present, to warrant the assertion of P. So when we say that Goldbach's conjecture is not proved, we mean there's not sufficient evidence now to warrant the assertion of Goldbach's conjecture. Since this is weaker than asserting that there could be no verification of P, like there just couldn't be one, it just says that there isn't. So the modal is replaced by a non-modal. It allows the verificationist to adequately express that a certain proposition is presently unknown. So I'm going to use, as I said, this kind of tilde thing here to express, the empirical negation of the proposition P. Now, this is just a standard Kripke model for intuitionistic logic. So I won't give it for the connective yet for the empirical negation, or did I? Oh, sorry, I will. Not for the other connectives. But a Kripke model is just this quadruple here with this non-empty set of worlds or evidential states, let's say. They're pointed models, so there's a base state in them, G. So truth in the model is truth at G, or a verification proposition is verified in the model, just in case it's verified at G. And that's going to be thought of as sort of the present evidence, evidential state or state evidence. There is a partial order, so reflexive, transitive, and antisymmetric on W, standing for evidential expansion. So the successor of one state is seen as a sort of evidential expansion of that state. So you get more evidence. And you have evaluation that interprets the atomic sentences here. So V, that's upward closed. So whenever U is a successor of W and U is in VP, then W is in VP, then U is as well. So that's known as heredity or persistence sometimes. Now the truth conditions for the connectives are as follows. So this says that in the model M at state W, P is true if and only if it's in the interpretation, W is in the interpretation of P in the model M for the atomic sentences. And a conjunction is true just in case each of the conjuncts are true at W. A disjunction is true at W just in case at least one of the disjuncts is. The conditional is true if and only if for all successors X of W, if the antecedent is true at X, then the consequent is. So it's a strict conditional. And the falsum is true nowhere ever. And here's the more interesting clause, that the empirical negation of P is true at a world W if and only if P is not true at the present evidential state. So there's not sufficient evidence at present to warrant the assertion of P. So that's the intuitive idea behind the final truth condition. Then we say that a model verifies P if and only if its base state does, and a set gamma of sentences entails P if and only if for all models M, if M verifies each member of gamma, namely its base state does, then M also verifies P. So it's preservation of verification over the base state. Now, this is an axiom system for this logic in conjunction, work in conjunction with Hitoshi Omori. It's a standard Hilbert system for intuitionistic logic. So axioms 1 and 2 for the arrow, 3 and 4 conjunction elimination, 5 conjunction introduction, 6 and 7 disjunction introduction, axiom 8 disjunction elimination, and the new ones are just axiom 9, 10, and one of the rules. So axiom 9 is excluded middle for the empirical negation. And then axiom 10 is a kind of ex falso quod libet for the empirical negation. So if you have the empirical negation of not A and then the double empirical negation of not A, then anything follows. And then we have modus ponens, and we have this fairly unusual rule RP. So from A and B, you can infer not A, arrow B. Right, so if A or B is true at the base state, then either one of the disjuncts is, so if in a successor state A fails at the base state, then B must be true there. So it will be true all the way up by persistence. So that's a semantic, shows that RP is sound. Now this system is sound and complete with respect to the semantics. Here are some notable theorems. So we have double negation elimination here for the empirical negation. We get the De Morgan laws, the intuitionistic negation of A is strictly stronger than the empirical negation, strictly stronger because you don't have the converse down here in the non-theorem section as it stated. And then, yeah, you have mixed double negation elimination, kind of ex falso quod libet, a rule form of contraposition, and so on. And here you see what you don't have. So in arrow form, you don't get any of the directions of, you don't get classical or intuitionistic contraposition. You have this in rule form, but not arrow, and likewise for the arrow form of ex falso quod libet. And yeah, so there are some similarities to also strong negation of Nelson that some of you might be familiar with, but it's different. It looks fairly classical in certain respects, and but of course it's weaker than intuitionistic negation rather than stronger. But anyway, so these are some notable theorems and non-theorems that I just wanted to mention. Now, since the language we're working with also has a knowledge, an epistemic operator and a modal operators, as we saw in the proof of AR, we have to enrich the language and the semantics a bit. So now a model is this tuple here where WG and so on are the same as before, but we now have a monotonic epistemic function. So it's a function from worlds to sets of worlds, propositions, where W is in f of W for every W, and it provides the epistemic possibilities for a state. So this is the set of epistemic alternatives to W. That's what f of W is. And it's monotonic just in case you have this. So whenever U is a successor of W, then you have that the set of alternatives at U is a subset of the set of alternatives at W, right? So as your evidence grows, you can eliminate more possibilities. That's why you have this that's why this condition holds. Now, I did it in terms of a function, but you could just as well have done it using a standard accessibility relation. That's reflexive, but there were already some other accessibility relations in there. So, and I had wanted to do something different with it before. So anyway, I just left it as a function, but you can use just a standard accessibility relation as well. And then there's a accessibility relation R governing the modal operators. And finally, there's a verifier state G star such that the set of epistemic alternatives to G star are precisely the successors of G, the base state. So this means that, oh, and we have that G star is possible relative to G. Now the verifier state G star, what it's there for is to make valid AR. So for all P, if P is true, then we have that it's possible to know P. Well, where? Namely at the verifier state G star. So that always guarantees that every truth at G is known at an accessible state in the model. Then the truth conditions for the remaining connectives are as follows. So we have that box P is true at W if and only if for all X, if RWX, then X makes P true. And the diamond is the existential dual. There are, it's not straightforward to add the modal operators to intuitionistic logic because given the operators in the language, you can't make them duals in the usual sense as one being definable in terms of the other using the negation. But this is a standard, this would be like a standard semantics for these operators. Then you have 3, so P is known at W if and only if P is true at all the epistemic alternatives to W. So fairly straightforward there. And then here are some facts. Given the semantics, with the new operators, you don't break anything like the persistence condition. It holds for arbitrary sentences. And the modal operators satisfy the properties that are needed or used in the proof. So namely factivity, the alethic property, necessarily P than P, and this one part of a kind of duality principle. So necessarily not P, then not possibly P. And we also have that K satisfies the properties that are used in the proof, namely factivity. So if P is known, then it's true, and distribution of K over conjunction there. So what that shows is that the way the proof is going to be blocked in this logic doesn't rely, it's not because we're doing something with the box or the K, the modal operators, the epistemic operation. It's really a solution that relies solely on the negation. And as I remarked, the verifier state G star secures the validity of AR, and that's why it's there. So how does this all go towards giving a natural solution to Fitch's paradox? the revised line 3 would now look like this. So instead of it's known that P and then we have the intuitionistic negation here, now we replaced it with the empirical negation. That is verified by no model, right? So we assumed 3. Imagine you can know that P and P isn't known. That can be verified in the model, as you could check, but it can be verified at some point in a model. So no model verifies it, namely no base state does, but there are points in the model at which that can be true. And intuitively, this is because it's possible that at some evidential state, say in the future, I mean, you shouldn't always think, it doesn't always work to think of the pre-order as a temporal one, but it can be helpful. One can know that P, at some future state or future evidential expansion, you can know that P while also knowing that P was earlier unknown. So that would be one way of making sense why that revised line 3 can be true or verified somewhere in a model. Now, because of this, the following subproof is invalid at the last step. So we have this assumption 3 here, and from there we distribute K over conjunction. So we get 4, and then we use factivity of K, we get 5, and it looks like a contradiction, and it is. It's no model verifies that, of course, but it doesn't allow us to use reductio for the intuitionistic negation to get line 6. So the step from line 5 to 6 is now blocked just because P is known and there isn't sufficient evidence at present to know P. We can't conclude that 3 is false at any future, say, evidential state. So reductio for the intuitionist negation fails in this logic. Now you might think, well, what does 5 give us? So we can't use intuitionistic reductio. Sorry, here's before I mention that, here is just a little model showing how the state G here makes true this sentence that it's possible to know that P, and yet that there isn't sufficient evidence at present to warrant the assertion of P. So this would be in some other state other than G, of course. So this is accessibility related. So U is possible relative to G. All its epistemic alternatives make this true. So you just make P true at U prime, U double prime, and U, of course. And this conjunct here, that the empirical negation of P is known, is true because P isn't known at G because there's an epistemic alternative at which P isn't true. So at G, it's not true that P is known, or it's not verified. And so that you get this being the case everywhere in the model. Yeah, so what do you obtain from the contradiction at the new line 5? Well, you do have empirical reductio. So you have reductio ad absurdum for empirical negation, and you obtain this line here. So you get its necessitation, because that's valid, or a theorem. Well, we don't have a logic, actually, for the K in the box and diamond. The box and diamond being problematic, actually, but we do have that's valid. But now the move from line 8 to 9 is no longer valid because this duality principle fails. So remember in one step of the proof that we had that this necessitation implied that not possible, that KP and not KP. And that contradicted one of the earlier lines in the proof, namely that it was possible from our assumption in the anti-realist principle. So the proof is still blocked long before any line that looks problematic. So if I just go back, So we're sitting here at line 8, except these negations are empirical, and you can't get this principle here when this negation is empirical fails, so you can't get to line 9. So the furthest you can get is to line 8, and is that bad? No, that seems intuitive. It's necessary that um, there's not sufficient evidence to warrant the assertion that it's known that P, and yet there's not sufficient evidence at present to warrant the assertion of P. If you think of that reading of the negation, then this is entirely plausible. And also this failure of duality, this version of this direction of duality is plausible as well, because what this says is, so the fact that P is presently untrue, which is equivalent to this, because if P is untrue, then that's true everywhere in the model, because it just means P fails at the base state. If P fails at the base state, that's true for every world, right? So that's this thing here. So what this says is P is presently untrue. I mean, it's logically equivalent to that. It's stronger than that. In fact, it's substitutable salvaguarded data everywhere with not P. It doesn't entail that P is presently impossible. So it doesn't say those. That's obviously not a conclusion that you would draw. The fact that P is presently untrue doesn't entail that P is presently impossible, which is what this not diamond P says. It says there's lack sufficient evidence now to warrant the assertion that P is possible. Well, maybe that's a little bit too strong of a reading for that, but still, it's if you read it as there's a lack of sufficient at present to warrant the assertion that P is possible, that still wouldn't be entailed by the fact that P is presently untrue. So even if you read it in the weaker way, you would expect this inference to fail. Now, I hope this solution is more or less clear out now after having presented it. If there's no questions of clarification, I wanted to discuss some objections to this. So here's one objection. Suppose that W makes true the double empirical negation of P. So this is true if and only if the base state makes P true. So the double negation is true anywhere in the model if and only if P is true at the base state. So the double negation says something like, we now have sufficient evidence at present to warrant the assertion of P. But if it's true at the base state, if P is true at the base state, then the double negation is true everywhere in the model, including every epistemic possibility, because the epistemic possibilities are just drawn from W, just like the states of the model, the evidential states. So then we get this. If the base state makes KP true, if the base state makes not P true, then it makes KP true. So we have this entailment from not P to KP, and in fact, the stronger conditional form actually holds. And you might think, well, that looks bad. It says that if P is, verified at the present state, then P is known. Now, what I want to say is actually, ironically, in some ways, sort of similar to what Dummett said. So the double negation of P says it. You might read it as, well, that says that if P is true, then P is known, right? But the double negation of P doesn't say that P is true. That's just what P says. And you might say, hold on, the double negation of P is logically equivalent to P. That's true, but they're not intersubstitutable in all contexts. So before I get to that, let me just say this. Um, the way you should read the double negation of P is that there is sufficient evidence at present to warrant the assertion of P. And that's not how P should be read, because that other states it doesn't say that. It just says P is true at the state of evaluation, let's say. Now, if that were true, if there were sufficient evidence at present to warrant the assertion of P, then that must now be available to us in such a way that it epistemically rules out not P possibilities, right? If we now have the evidence to warrant the assertion of P, then P must be known. So I think that this objection fails because this is indeed a plausible principle on the current semantics. It's important to note that even though P and not P are logically equivalent, they do have the same. They do not have the same meaning, as I said, because they're not intersubstitutable, preserving truth value. So the double empirical negation of P is actually stronger than P. So it implies it in the arrow form, but not conversely. Now, what would be problematic are these two things here. If P, then KP, which is invalid, and if necessarily P, then P is known. That's also invalid too. So I think this is not, this is not worrying. Yeah. Now, if you're familiar with some of the literature, then you're probably familiar with Edgington's actualist strategy. And given this objection that I discussed, you probably may have thought of it in the back of your mind. So suppose some proposition P is true but unknown. Intuitively, this is equivalent to the proposition that actually P is true but unknown, which I'll symbolize this way. And these are the truth conditions. So actually P is true at a state just in case P is true at G. So this is definable in our semantics in terms of the double empirical negation. Now, actually P and P isn't known together with the anti-realist principle yields that it's possible to know that actually P and P is not known in place of the original line 2, which doesn't have this actually operator here. And this statement is not intuitively paradoxical and doesn't intuitively yield the result that every truth is known. So intuitively, this gives us a solution to the knowability paradox, and that's Edgington's proposal, is that we should guard these sentences here with an actually operator. So what you do is you restrict the anti-realist principle to say that it's not true that for all P, if P is true, it's possible to know it. It's true that for all P, if P is actually true, then it's possible to know that P is actually true. Yeah. And in this case, the reason that this is possible, the sentence here, is that, or the reason that's true is that you could know from some non-actual situation that actually, looking at the actual situation, P is true and it's unknown. So from some non-actual perspective, you can know that actually P is true but not known. So that seems intuitively plausible. And of course, AP and P are logically equivalent, but again, they don't mean the same thing because they're not intersubstitutable everywhere. Now it looks similar, as I said, to sort of what I'm doing because we can replace AP with not P. However, since AP is logically equivalent to this, as box not P would be on the empirical negation proposal, it faces this well-known problem that you get this. For all P, if P is actually true, then it's known that P is actually true. Because if P is actually true, then necessarily actually P. So every epistemic alternative will also be one at which AP if it's necessary. So if necessarily P, then P is known on the usual semantics. And that sounds quite implausible as well. Just because P is actually true doesn't follow that it's known that P is actually true. And we can think of many counterexamples to that. Now, you could distinguish, say, epistemic alternatives from metaphysical ones, let's say. To get around this problem, Edgington doesn't discuss this, and there's a different strategy, which is to go two-dimensional solution of Rabinovich and Segerberg. But still, one major difference between this and the empirical negation strategy, this is ultimately a restriction strategy. So it restricts the anti-realist principle, and I think that's unappealing. It should hold for any proposition whatsoever, not just those that are actually restricted to some form like actually P. Moreover, in this framework, you can derive this thing anyway, which is problematic. So even if you don't have that problem up here, you get that if it's known that P is actually, you get it's known that P is actually true, and it's not actually the case that P is known. So you can derive that from the assumptions that's used in the Fitch paradox. Now that looks pretty bad as well. So that would be true, that would be valid. So it would be true at the actual world of the model that actually, so this would be actually true, that it's known that actually P, and this would be actually true, that it's not actually the case that P is known. And I think those sound like a contradiction together. And I finally just want to quickly discuss this last related paradox, which is actually really got me thinking about this problem ages ago. And it's in this paper, Never Say Never by Williamson, much lesser known than the stuff he wrote on the Fitch paradox. And he argues that P will never be decided, the statement, P will never be decided, is intuitionistically inconsistent. Now, the way he does it is he uses Fitch-style reasoning to argue for this conditional here, this implication. So if it's not the case that P is known, then P is not true. If we had contraposition, classical, that would be equivalent to P. If P, then P is known. But suppose we don't even have that. The idea behind this, I think I put it here. He says here, the problem is that there seems to be an intuitionistically valid argument from, as I said, not K, not A. Consider the conjunction A, and it's not known that A. Could you ever possess a warrant to assert that conjunction? If so, then you would know the conjunction. Then you distribute the K over and so on, and you're in trouble. Then KA would be true. For a warrant to assert a conjunction involves warrants to assert its conjunct, so the second conjunct would be false, so the conjunction as a whole would be false. Thus, one can possess a warrant to assert A and, I think that should say not KA, only if what one asserts is false, but that's such a self-defeating warrant is evidently not a genuine warrant at all. So no one could ever possess a warrant to assert this conjunction, even in principle. So you can negate it, intuitionistic negate this conjunction, and that intuitionistic negation of this is logically equivalent to this. Now, he actually considers using empirical negation to block this dilemma, this paradox, not dilemma, this paradox from the statement that P will never be decided to a contradiction. I never explained that actually. So P will never, or A will never be decided would be stated like this. So it's not the case that A is known at, if you read K as is known at some time, or the negation is known at some time, then by intuitionistic intuitionistically safe De Morgan, we get this. And given this thing that he argued for, this implication, so this reduces, this implies this. And that's obviously intuitionistically inconsistent. Now, he thinks ultimately that the empirical negation solution won't work because he thinks it should be stronger empirical negation than intuitionistic negation. So he thinks that this ought to be valid here. But then this would imply this, and we're back in inconsistency. Now, why does he think the empirical negation is stronger than intuitionistic negation? He says this: for if the empirical negation is to count intuitionistically as any sort of negation at all, not A should at least be inconsistent with A in the ordinary intuitionistic sense. It's not clear what he means by the ordinary intuitionistic sense. I guess he just means this. A warrant for A and not A should be impossible, he says. That is, we should have this. Now, on the current semantics, the intuitionist negation of A is stronger than the empirical negation. It's actually the other way around. But we do have this, as he says, a warrant for A and not A should be impossible, because you could never, in any present state, be warranted to assert this. So this is never true at the base state in any model. So it's impossible, but you don't get this because there are states at which this is verified, namely a state at which A becomes verified, but it wasn't verified at the base state. So A and not A is impossible, but you don't get the intuitionist negation of it. So I think there's good reason to think that what he says, to believe everything he says except the last line there, that A and not A may be impossible without implying the intuitionist negation of it. So that's one way to read impossibility. But in this framework, there's another way to read impossibility. So there's two senses, one in which it could never be verified in a model, and another in which it means couldn't be verified at any state in any model. And that's a much stronger sense that I don't think is the right sense of impossible here. So that's that's all I wanted to say, and I accidentally forgot my thank you slide that I wanted to add in there. So anyway, thanks for listening.